Hello. In this video, I want to teach you about the mole ratio. So this is a chemical equation. You should think of it like a recipe in a cookbook. It says that if you add 4 atoms of aluminum and 3 molecules of O2, then they will combine together to create 2 molecules of aluminum oxide. Now, if this is true for individual molecules, it's also going to be true for groups of them, as long as the groups are the same size. This is what I mean. If I add 4 dozen aluminums and 3 dozen O2s, then I will get 2 dozen aluminum oxides. Now in chemistry, the most important grouping is not the dozen, even though you may have heard of it before. It's the mole. And a mole is a group of 602 sextillion objects, approximately. It's just a group though, it's the same as a dozen. So 4 moles of aluminum and 3 moles of O2 will combine together to create 2 moles of aluminum oxide. The fact that all the groups are the same size is really important, and it lets us figure out the ratios between groups of chemicals that are being used in this equation. For example, if I wanted the ratio between aluminum and O2 in particles, it would be really easy to find. I would just look at the coefficients and figure out how many particles of aluminum I have to use, and then how many particles of O2 I have to use. By the way, a particle is a molecule or an atom or a compound, anything like that. So I would need 4 particles of aluminum to 3 particles of O2. That should hopefully make sense. That just tells me what the recipe asks me for. You get the numbers from the coefficients on the matching chemicals in the equation. And to get a ratio, you're going to look at only 2 chemicals at a time. You ignore everything else. The important thing here for the future of this lesson is that although this is the ratio of individual particles, it's also going to be the ratio of all similarly sized groups. And when I say similarly sized, I mean if you have 4 dozen aluminums, you get 3 dozen oxygens. Or 4 pairs of aluminum, that corresponds to 3 pairs of oxygens. Or 4 moles of aluminum will correspond to 3 moles of oxygen. Because you would multiply the numerator and the denominator by the same number, like for dozens it would be 12, and then because you multiply the top and the bottom by 12, they cancel out. Therefore, the particle ratio, that's also the ratio of all similarly sized groups. So that's the dozen ratio and the molar ratio. Now, nobody cares about individual atoms. They're too small to ever matter. And groups of a dozen atoms are similarly small and don't really matter. The only grouping big enough to matter is the molar grouping. That's why chemists invented the concept of a mole. And we call this the molar ratio. So the mole ratio is the ratio between the amount in moles of any 2 chemicals involved in a chemical reaction. All you do is you look at the coefficients of the chemicals, and then you write them down in front of the name of the chemical. You can write it down in several different forms, like, for example, you can write it as a fraction, or as an equality, or with a colon, but the important thing is the numbers come from the coefficients in the chemical reaction. That's the important thing. Let me do some quick demonstrations. I have this equation, which is photosynthesis, carbon dioxide and water mixed together to form glucose and O2, and I'm going to write the mole ratio between some chemicals in 3 different ways. First, as a fraction. I need to know the number associated with O2, which is a 6, and the number associated with CO2, which is a 6. So the mole ratio as a fraction is 6 moles of O2 over 6 moles of CO2. Now I'll do it with an equal sign. It's the same process. I look for the coefficient in front of the water, and that's a 6. And then I find the coefficient in front of the glucose, and that's a 1. So the mole ratio is 6 moles of water to 1 mole of glucose. Finally, with the colon, it's the same thing. I look for the coefficient in front of the glucose, and that's a 1. And then I also look for the coefficient in front of the carbon dioxide, and that's a 6. And that's it. 6 carbon dioxides to 1 glucose. These are 3 different valid ways of writing the mole ratio between 2 chemicals using this reaction. I hope that was helpful.